Hi, it's Dave from MegaPoints Controllers. On this video I'm going to walk you through the installation of an MQTT broker, which is a piece of software for your PC. Now the MQTT brokers are available for Windows, Linux, Raspberry Pi, Apple Mac I think as well. So it's a piece of software that coordinates all of the Wi-Fi messages. It's probably going to take less than 15 minutes to walk through it, but I thought I'd go from beginning to end so you could see what's required, and I'll just take you straight through to the answers and bypass all of the noise that you can get lost in sometimes. You need the broker so that you can then enable the Wi-Fi functions on our System2 range. I'll provide an explanation of what the broker does and competing technologies at the end of this video, but for now let's just get going and you can see how easy it is to set up. Okay, so here's my PC. It's a Windows 10 PC. There's nothing special on it. It's pretty standard, I think. So what we'll do, we will head over to the Mosquito organization and pick up a copy of the Mosquito MQTT broker. Mosquito.org and download, and for me I want the Windows 64-bit version. I can download that, and great. And what I can do now is copy it from my downloads location, which is here. I'm going to put it on my desktop. Right, so what I'll do now is I'll double click the installer, and I'm just going to take the defaults. So yep, I want you to make changes. Yes, go ahead, next. Take the default installation location. And it's having a think. Of course it is. And we're done. So that's the installation. Well, I would say complete, but we need a little bit of configuring. So the first thing is, if I start the Windows services, we can look under M for Mosquito, LM Mosquito broker. There it is. And we can see that it's currently stopped. If it's running, start, you can stop it like this. So I'm just going to stop it because I want to modify a configuration file. The next thing I'm going to do is, if we go into the directory where Mosquito is installed, let's put this on the same location of the window. So it's Program Files and Mosquito. And there's a little configuration file here, and I want to shortcut you to the quick config there. So what we're going to do, we're going to start Notepad, but don't just click on it, right click on it and select Run as Administrator. Heed the warning and say yes. Now we're going to go over to File, Open, and we're going to go to C drive, Program Files, Mosquito, and we're going to set the file type to all files. And we can see there's mosquito.conf there. So I'm going to open that, and it's got all sorts of things in it that honestly we don't care about. So I'm going to select it all with Control A and delete. Now what you want to do is you want to create two entries in there, and they are listener space 1883, which is the default listening port, and allow underscore anonymous space true, and that means you can connect to it without using a username and password. Once you've made that change, close the window. Yes, I want to save it. Close that. Now I can go to my Mosquito broker and I can start it. And if you look now, you can see it is running, it's shown as a status of running. So that is, in the space of 2 minutes, Mosquito Broker up and running. Just when you thought you were finished, you weren't. There's a gotcha with Windows, and that's the Windows firewall. So if I type in firewall into my start menu, let's open that up, and I'm going to allow an app or feature through Windows Defender Firewall, change settings, and I'm going to allow another app. And now I'm going to browse, and I'm going to go to C, Program Files, and I'm looking for Mosquito, and I'm going to do mosquito.exe. Add, and there it is, and I'm going to allow it on the public and private network interface. So that's my firewall configured. Now this is entirely optional, but I think we should install a little tool that lets us see the data flowing so that we can confirm everything's okay. So we'll head on over to MQTT Explorer, MQTT Explorer. If we search for that, mqttexplorer.com. We can download it. I'm going to take the Windows installer version. There seems to be lots of different versions. You can run this on the same PC as your broker. You can run it on a different PC. Doesn't really matter. Downloads, and it's still coming down, almost there. Great. So I'll just copy this or move it onto my desktop. Double click it. And we are ready to go. So let me delete my saved connections. Don't want to cheat. So first of all, we need to open a connection to the broker. So let's call this video demo. So what's the name of the host? Well, it's on my PC, so I could put the local host address in, but let's assume you're on a network and you have to figure out what that host name is. If your host is in DNS, you can just enter it, such as ZM3, and I know that will work for me, but I've configured DNS, so we'll skip that. So what I'm going to do, I'm going to open another window, my command window, and I'm going to type ipconfig, and here there is, under the IPv4 address, 192.168.0.115, and that's the host I'm going to enter. 192.168.0.115, if I can type, save, and there's no username or password. Connect. So if you see something at the top, this is the name of the broker on the network. If you see a sys and then you open it and a broker and you see information, then you are connected to the broker and the broker is running because it's getting all this information from the broker. So you are fully configured and ready to go. Let's see some actual data flow and configure the MegaPoints System2 devices to use this. So I'll close some windows, clean up my desktop. Don't need this anymore. So I positioned the MQTT Explorer next to the window for the administration interface for a servo driver. So if I set the protocol to native, then I can tell it the name of the broker, and the broker is, in this case, 192.168.0.115. Now I want to save and I want to reboot. And if you look now, we've got this MPC folder here. That's MegaPoints Controllers. And if I expand it, you can see there's an announce topic and there are various vports. And if we look, these are the feedback vports 161 to 168, which match these. So we can see now that our servo controller, our servo System2 servo driver, has communicated with the broker and told it this is how the points are set. So we know it's talking to the broker, looking great. So let's connect now to my newly patched panel controller. What's the address? It's panel 8FF4B, and it's pulled it out of the cache. And there's the panel, and you can see it's on revision 4, so it's good to go. So I'm going to set the protocol on this to native, and I'm going to set the broker to 192.168.0.115, save changes and reboot. Keep your eye on the MQTT Explorer here. And can you see there's all sorts of other information coming down now? So the panel has communicated vports 1 to 16. The numeric order's a bit odd. It starts with the 1s and then the 2s and then the 3s, but hey ho. So if I look at vport 1 here, it's set to 0, which is an off. If I press the button on a panel controller, it's changed to a 1 and the corresponding servo has moved. Changed back to a 0. And if you look at the feedback port for the servo on channel 1, which is address 161, then there's a 161 here, and if I press the button on the panel controller, you can see that changing, and it changes from a 1, in this case, to a 3, then to a 0, then a 3, and then a 1, and then a 3, and then a 0. What's the 3 all about? Well, that tells the panel to flash the lights. So if it sees a status of 3, it flashes LEDs. If it sees a status of 1 or 0, then it will just move the light to that position. So here are the boards on the bench. If I press button number 1, is it in camera shot? Yes. You can see the servo move and the lights flash. And the flashing starts when it sees a 3, and it stops when it doesn't. Now we can be a little bit more creative as well, because this Explorer is a useful diagnostic tool. For example, if I set this to, if I set the topic to MPC vport and then I do /1, I set the data type to raw. If I put a 0 in there and select publish, okay, nothing happened because the servo's already at one position. Now I'm going to change it to a 1. Can you see how the servo's moved and the panel's changed its light as well to indicate that it has moved? I'll go back to a 0. So you have a fully working MQTT installation at this point. In this case, I'm using native mode. One board is talking to the other. For those who have difficulty sleeping, here's a little more background information. This is entirely optional, so you don't have to watch it if you don't feel you need to. Well, you won't need to. But it just, I want to go over why MQTT is so useful and some of the other protocols we considered. If we go back to our earlier boards, here's an early one. This uses the ESP8266, and we have ESP32s as well on boards. We tried a protocol called ESP Now. And what that does, that allows you to tell each board to communicate with the number of other boards on a network. So you could have a board here and a board here and so on, all around your network, and communicate with each other. And the communication that we require really is that of the ability to effectively broadcast. If these were connected to a CAN bus, like so, then when a message is sent on the CAN interface, every other board, so if this guy sends a message, every other board receives that message and then decides whether to, whether that message is meant for them or whether it discards it. And that's a great way of having a broadcast network, and it's the network that your car uses, and it's great. What ESP Now does is on the Wi-Fi, it uses ESP's protocol, and it tries to hide the physical wiring. So we're using Wi-Fi now, and each board maintains a list of each other board, and so every single board on the network has this list of boards that it should communicate with. There might be something else on your network and it should not communicate with that. So when this guy sends a packet to somewhere else, and the thing is, the board that's sending the data doesn't actually know who it's intended for, it just knows it has to send it. So it will transmit it, and because there's a list of, in this case, 5 other boards here, it will drop down the list one at a time, and it will transmit that data on an individual basis to that board, and then it will get an acknowledgement, then to this board, then to this board, then to this board, then to this board. And because we're no longer a broadcast network where we just put something on and it goes everywhere, we're having to manually take control of that. Suddenly the overhead of that protocol is quite high. It's quite an expensive protocol. So we're sending data here and we're getting an acknowledgement back. If we don't get an acknowledgement back, then it's up to us as the application developers to then go, okay, nothing happened in an agreed time frame, retransmit it. So we're taking care of how to transmit data and get it to wherever it needs to go. So if this board sends the data here, this board has to acknowledge it, even if it's not intended. It's sent it a message, it has to say acknowledge or go through this timeout loop. So it's expensive. The second thing is, with ESP now, you can only have, I think, 15 nodes, or I think up to 20 with no security. So the scalability is greatly limited, and that's no good for us because we want to use the same protocol whether you're running 2 boards or 200 boards. Why should there be a difference? So ESP now got a big no from us. Another protocol we looked at, and you may have seen a video from last year with this, was using LoRa. LoRa means long range. It uses about 900 megahertz, 858 I think. And this can send a signal, 10 to 13 kilometers. When you look into the detail for LoRa, so we've got LoRa. When you look into the detail, you can only use full power with a limited duty cycle. And that means basically you can only send data to a specific rate, and it might be, for example, send a packet out and then we can't transmit anything for another 20 or 30 seconds on this device because it doesn't meet the specification. Or we use a different part of the band and we use a much reduced power setting, and then there is no duty cycle requirement and we can send data all day long at any rate at all. And when I built and designed this and put the software on, wrote the software for it, I set it to go into the lower power, no duty cycle limitation part of the band. So this guy, through its antenna, could send messages out all day long, and it was, sending them out on the radio and so on. And there could be another board here that is receiving. Now, LoRa's great, but it's quite slow. So to send a packet from that board, it would take something like 20 milliseconds to send it. And it transmits it to everything. And then you've got the problem. Do you want to do a handshake? Do you want this board to say, got it, thanks, acknowledged? Or do you want it to ignore it unless it's intended for that as a recipient? So you get into all these protocol overheads. And before you know it, with lots of boards sprouting up, if you choose to acknowledge everything, then you've got lots and lots of data being shared over the radio at quite a low bandwidth. And you start to see noticeable pauses in telemetry. Now, I think, and we still may do this, I think this protocol would be excellent for somebody with a large outdoor railway where they tend to have greater distances and less density. railway than say an N-gauge layout, which could have 50 or 100 points in a very small space. So this isn't given up, we are just re-evaluating this for later. If we look at a wired network, so say we're running on Ethernet, for example, we have a number of boards on our Ethernet cable, and we can all communicate, and that's fantastic. Ethernet is great, but the beauty of these boards is they work through Wi-Fi instead, and it's the lack of cables that's the attraction for somebody who wants to use this board. So we can run the same protocols on Wi-Fi that we can on Ethernet, or at least to the untrained observer they look the same. So this will now go out on its little Wi-Fi antenna, and it will look like the same network, because effectively we're going to be running TCP in both cases. TCP is Transmission Control Protocol. Gosh, I can't write P. And it takes care of the communication between each device. But TCP, the problem with TCP is it can't broadcast. It will send a packet from here specifically to another address. And that's a bit like the ESP now. So if I want to send this to all boards, I've got to send an individual packet addressed to the recipient on the network. And that means that my little tiny device is spending more time talking radio than it is talking, doing useful work. Now, there's a little bit lower down, there's something called Internet Protocol, IP. And IP takes care of the naming and the device addressing. You saw on the broker, we set up a device address of 192.168.0.115. That's IP, and it's the IP address that we set up. So to go with all this network configuration, there's another protocol. Instead of TCP, you can go UDP, User Datagram Protocol. Now that's very different. UDP allows you to put something on the network and broadcast it to every single node. So before you go, aha, that's the protocol to use. It's great on wired, but when you get onto this wireless side of things, it gets a bit hairy, because first of all, the wireless at 2.4 gig, it's not full duplex, it's half duplex. So everything shares the same frequency. You can't have more than one device transmitting at any one time, or it will cause a collision. Now, the protocol deals with that, detects it and retransmits and so on, so that's okay. But if we send a packet on UDP, so we want UDP/IP instead of TCP, we can put something out and transmit it to everything. But during testing, we determined that about 25% of all messages didn't get through. And that's unacceptable for a control system. If you're watching a movie, losing packets here and there or dropping frames is not an issue, you wouldn't notice. But when it comes to a control system where when you press a button, it has to respond, then that would be clearly unacceptable and is just of no practical value. It's really flaky. So now we come on to MQTT. Message Queuing Telemetry Transport. And what that does is that puts a host in the middle called your broker. It's just a server, nothing more. But they call it a broker because it deals with these specific messages. And then you have a number of nodes all around, and they could be on your network, they could be anywhere in the world really, because this scales to absolutely vast proportions. Now, instead of having something that can broadcast anywhere, or something that is point to point to give you this guaranteed message delivery, we can have it that every node transmits to and receives from the broker. So it's got its own dedicated line, if you will. And we can tell this what quality of service we want. So we could have a fire and forget, we could have you must deliver this to everyone who's interested at least one time, or you could have it the highest overhead, which is deliver this message only once to all those nodes that are interested. So with every node connecting to send and receive, we have this network built up of which the broker is the guy in charge. Now, the way this works is it uses what's called a publish and subscribe model. And what happens is when these devices, say it's a servo controller, starts up, it will subscribe to a number of topics. And each topic in our case would be for our native protocol. It would be MPC, MegaPoints Controllers, vport, and then the vport number. So a Servo 8 driver would immediately connect to 8 topics on vport 1, 2, 3, 4, and so on. So it's subscribed to the broker on the particular channels. So if I've got a panel controller here that sends a message that says vport 7, change the data and set it to off. The broker looks internally and it says, who is subscribed to vport 7? And it'll go, ah, this guy is. So I'm going to send the data there. And also, this guy also subscribed to vport 7 because he might be listening and setting a light to match. So the broker takes care of the communication to distribute that information around the network. Where it gets scalable is because these boards were subscribed to that vport, it's only publishing the information where it needs to go. It's not sending it here or here or here. It's not wasting the time of any other board. So it's minimizing the amount of messaging that needs to take place. Now, I remember years ago working on the old IBM airline ticketing systems and so on, and they used an MQ product, a message queuing product globally, and it handles thousands and thousands of messages a second. So it's a different scale, but it's the same idea. If I'm running the broker on a tiny little Raspberry Pi and I've gone from 8 boards to 80, well, if the Pi is getting a little bit busy because it's not big enough, we can put it on a Linux PC or a Mac or a Windows PC and we can scale it up. You can even go into complex situations where you have multiple brokers linked. There's all sorts of stuff to do, but in our case, we just need a very simple broker that allows us to subscribe to particular topics and to publish to topics. And when I had the MQTT Explorer on the screen, you could see that I was typing in a topic name and sending data. So I was passing it out, and the broker was simply going, where's that information need to go? And it sends it. And we use a QoS of 1, which means we've a guaranteed delivery. So the broker automatically guarantees to get the data there, assuming the node is available and up, because it will use a TCP connection between the two, which gives us order integrity and data guarantee. There's a whole handshake that takes place. So I hope that didn't overdo it for you, but in essence, you run this little tiny piece of MQTT broker software on your PC or wherever, and everything connects to it, and away it goes. So if you made it through the protocol and broker explanation, well done. It's all off the top of my head. I haven't really done networking for years in any great detail, but it still comes in handy. It seems to follow you around wherever you go now, because we live in such a connected world. So when you hear all this Internet of Things stuff, well, that's what this is. It's exactly Internet of Things. And that's why when you turn on, you shout at your Alexa or your Google device, you now know what protocol is going on under the hood, which allows it to connect to devices like a light bulb that don't appear to be connected, or where you can shout instructions into a mobile phone 10 miles away and it will turn a light on in your house. So thanks for watching anyway. I hope it was useful, and hope you find it easier to fall asleep. Cheers.